Hello, I'm going to do a few videos of drawing diagrams for the geometry part of the Maths Applied course. I'm going to do some questions from the 2012 exam paper. Here's question 8. They always come with a bunch of words at the beginning, and before you write anything or start to draw anything, you should spend a little moment, just read the words and think about what they're actually talking about, and then we go into it. So I suggest you just read that, maybe pause the video for a moment and read that and have a think before you then watch it as I go, how I would go about this sort of question. Right, we've looked at the question, we know what's going on, hopefully, and here we go. Margaret is at the top of a lighthouse, so I draw a lighthouse. There I am, up in the air. Margaret's at the top, ground at the bottom. That'll be a right angle. Looking east, this is east going in this direction, west going the other way, and she notices a beach at an angle of depression of 19 degrees. So somewhere along this way going east, maybe there's a beach. Angle of depression. Angles of elevation and depression have to be measured from the horizontal. So I'll put in my horizontal line, and the angle of depression to that one is 19 degrees. I'm going to fill in another bit here whilst I'm doing that, because if that angle of depression is 19, it means the angle of elevation going up from there to there is also 19 degrees. And that's always the case. The depression from one side is the same as the elevation from the other point looking back up. Okay, that's the first bit done. There's a rock further away. So if there's the beach, the rock must be further away, or over here. And this one's an angle of depression of 10 degrees. So I'll draw that line. Beautifully done with a ruler, as you would imagine. And we have 10 degrees. Similarly, that'll be 10 degrees down here as well. The angle of elevation going up, the same as the angle of depression going down. And the rock is 119 metres from the beach. Rock to beach, 119 metres. We can fill in quite a few other things on this, and I'll do that now. I'm not going to do the calculations in this video, but I am going to keep filling in this diagram because there is more we can put on there. If that's 19 degrees and that's 10 degrees, well, hopefully you can take them away and we'll end up with a little angle in between the two there. It's 9 degrees. Also, we've got a straight line here, which would be 180 degrees, going from one side to the other. If we went around like that. So that means that angle from there to there would be 180. Take away the 19, which would be 161. And I'll just check, I've got that plus that, 171. Yep, those three add up to 180, so it's all looking good there. And that's all I need to do for the drawing of the diagram. Though I'll talk a little bit about the calculations that are bound to be coming next, you should recognise this sort of picture. It comes up many, many times. Generally what we're going to get is a triangle here that doesn't have a right angle in, and we'll be using the sine rule or the cosine rule to work out some part of it. And then we have a right angle triangle here, and we'll be using the sine, the cosine, or the tan to work out the bit that we're trying to find. I think eventually we're going to probably try and find the height as a common sort of question here, but I won't do the calculations here. Hopefully that makes sense. Okay.